This is graphing linear inequalities. Linear inequalities can be graphed in the same way that linear equations can. All we need is a point and a slope. For example, if we had y is greater than 1/2 x plus 2, then we would use the same strategy we would with slope-intercept form. Our slope here would be 1 over 2, and our y-intercept, that b, equals 2. And we'll be able to graph from there with our rise over run and our y-intercept. Let's look at a little bit more examples here. Here are the two different types of lines. If it is a greater than or lesser than sign, it's a dashed line, because everything on that line, it actually wouldn't be equal. The dashed line means it would be not a solution. Let me move this out of the way. Points on the line are not solutions. However, if it's greater than or equal to or less than or equal to, it's a solid line, because everything on that line is also a solution. Now, the shading part. To determine which direction to shade, we use a test point that is not on the line. If the test point is in the solution, so is every point on that side of the line. If the point is not in the solution, we gotta shade the other side. So here, I provided an example. Y is greater than negative 1/3 x minus 1. So let's use 0, 0, that origin point, as a test example, because it's definitely not on the line. So if we plug in 0, 0 into this equation, or inequality, if 0 is greater than negative 1/3 times 0 minus 1. 0 remains greater than negative 1/3 times 0 is 0, minus 1 is negative 1. Is 0 greater than negative 1? The answer is yes. Therefore, this would be a solution, and something we would have to shade. Everything on this side of that red line is a possible solution, because it's greater than. It's not an exact line. It's not an exact point. However, if we did something below that line, let's go 0, negative 2. So y is negative 2 greater than negative 1/3 times 0 minus 1. Negative 1/3 times 0 is 0, and 0 minus 1 is negative 1. Is negative 2 greater than negative 1? No, it is not. So this and everything below this line is not a solution. The solution lies above in any of these points. Let's look at another example. Here we want to graph the solution to y is less than 3x minus 2. We have our mx plus b. We have our slope is 3 over 1, and our y-intercept is going to be 0, negative 2. Starting at 0, negative 2, we have a point. Our rise 3 and run of 1, we can use that to 1, 2, 3, 1, 1, 2, 3, 1. We can create a line from there. Something like that. It's not very straight, but we'll get better at it. Unfortunately, we're not done, because that line right there tells us it actually needs to be a dashed line. So let's change that line. That's a little better. We've got y is less than 3x minus 2. Now to see which side we should shade on, we need to plug in, let's go with 0, 0. That's a good spot, because 0 is very easy to multiply, and we have, it's definitely inside the dotted line. 0 is less than 3 times 0 minus 2. 0 is less than 3 times 0 is 0 minus 2. Is 0 less than negative 2? No. 0 is greater than negative 2. So this is not a solution, which means that everything to the right of that will be a solution. Everything in here. But not the dotted line. It has to be to the right of the dotted line. Here we have a graph in standard form. 9x minus 12y is greater than or equal to 96. We have to do a few steps first, including putting it in slope-intercept form. That's just going to make it easy for us as we go along. The first thing we should do is subtract 9x from both sides. Once we've done that, it should look like negative 12y is greater than or equal to negative 9x plus 96. The next step is to divide everything here by negative 12. Once we've done that, dividing by a negative or multiplying by a negative means we have to flip our sign. As you can see here, we've flipped our sign so that it now says y is less than or equal to 3/4 x minus 8. We actually can graph that here on the right. And it should look something like this: a solid line with the y-intercept of negative 8 and a rise over run of 3/4. But we still need to decide, does this work? Should it go above or below? With y is less than or equal to 3/4 times x minus 8. We can use 0, 0 again, because that's clearly not on the line, and a good place to start. So is the statement true? 0 is less than or equal to 3/4 times 0 minus 8. Is 0 less than or equal to negative 8? No. 0 is actually greater than negative 8 on the number line. So that is not a solution that works. The answer, and the part we have to shade, is everything below this line, including the line, because if it were on the line, it would still be true, because it's greater than or equal to, or lesser than or equal to. Give this a try on your own. Here's the try it problem. Which of the graphs below shows the solution to 3x plus 2y is greater than 8?